Okay, on this page of notes, we're going to cover the Pythagorean theorem. And although some of you might be familiar with the Pythagorean theorem, it's important to go through this because we're not only going to work with the Pythagorean theorem going forwards, we're going to practice working with our radicals, and then we're also going to do the converse of the Pythagorean theorem and introduce a little bit more vocabulary. So these are crucial notes. There are many proofs of the Pythagorean theorem, and you can really just Google proof of Pythagorean theorem to get an idea of why this equation is true. We're going to do one, or you will do one in your homework tonight to understand why it works, but understand that there are many, and you're welcome to go look at any of those. Just Google that. So our Pythagorean theorem is a squared plus b squared equals c squared, although the equation could be rearranged in c squared equals a squared plus b squared. The important thing about this equation is that c has to be the length of the hypotenuse. So although a and b are interchangeable, c has to be the hypotenuse. Remember, we only have a hypotenuse in a right triangle, so we can always find our c value by looking across from the right angle. Sometimes you'll know c, and sometimes you'll be asked to find c. So two quick examples here. If I'm asked to find the length of AB, it's always nice, assuming there's not already a variable in the question, to just put an x on whatever you're asked to find. If there had already been a variable in here, we could not just insert an x. Now, the next thing you want to do is find that hypotenuse and ask yourself, do you know it or do you need it? So when we set up our equation, we can simply do our x squared plus our 4 squared, although you're welcome to do that in your head, equals your 8 squared. From here, it's a very quick algebra problem. X squared plus 16 equals 64. X squared equals 48. And remember, we are not going to use our decimals. So when we take the square root of each side, we need to think about simplifying our radicals. For those of you who still need a little bit of guidance, remember that 48 breaks down into the perfect square of 16 times 3, which gives us our final answer of x equals 4 square root of 3. We can put a u on that for units. It's nice to remember to label our answers. On our next problem, when we're asked to find the length of CD, this time my hypotenuse is my unknown, so I can put my x there. So I'm going to have my 9 squared, remember the legs are interchangeable, plus, parentheses are important here, 3 square root of 5 squared equals our x squared. It's important to remember what it means to square something. It means to multiply it by itself. So this 3 square root of 5 squared I can rewrite as 3 square root of 5 times 3 square root of 5 equals my x squared. Now this is important because I'll still have my 81, but when I multiply these together, 3 times 3 is going to be 9, but square root of 5 times square root of 5 is 5. So I really have a 9 from the 3 times 3 and a 5 from the square root of 5 times square root of 5, or 45. It's going to make a huge difference in our answer. So we now get x squared equals 126. Again, we're going to take the square root of each side. We are not going to get a decimal approximation. We're going to find the perfect square in 126. It's going to be 9. So 9 times 14. So our final answer, written in its radical form, is 3 square root of 4, 14 units. So those are pretty straightforward, and we're going to use those virtually every single day. Now, the converse Pythagorean theorem is also an important idea. So the converse Pythagorean theorem says that if we take 3 sides of a triangle and we evaluate the Pythagorean theorem, putting the largest side in for C, if we get a true statement where both sides are equal, the triangle must be a right triangle. If we take the largest value and square it and find that it's smaller than the sum of the other two, then the triangle must be an acute triangle. If we take our largest side and square it and we get a value that's more than the sum of the other two sides squared, then it would be an obtuse triangle. So it is also important to remember that it's possible that we have three sides of a triangle that don't actually make a triangle. We covered that last semester. Not all values will actually make a triangle. So on example 3 here, we want to look at what types of triangles we get. And the first thing that you want to do in each of these problems is determine which side is going to be the longest. So on examples A, of course, we can clearly see that 16 is going to be the largest. On example B, there are several ways that you can do this. You could type this into a calculator and just type in 4 square root of 5 and figure out, is that bigger than 8 and 4 or is it smaller? If you try that one out, you will discover that it's the biggest. But don't be tricked that we always put the biggest one last, because if we come to our next problem, if you type 2 square root of 17 in your calculator, you'll actually discover that it is the biggest. Also, don't assume that the radical is always the biggest. That's also not true. So now we can simply evaluate our Pythagorean theorem. So we find our largest side, and I like to find the square of that one first. So 16 squared is 256. On my next one, 4 square root of 5 squared. Remember, I'm going to take 4 square root of 5 times 4 square root of 5, which will of course give me 80. On the next one, I'm going to take 2 square root of 17 squared. I can actually even just write that one out here, 2 square root of 17 squared, save a little bit of time there, and I get 68. Make sure you're comfortable with squaring each of those radicals. The next thing that we're going to do is we're going to find the sum of the squares of the remaining sides. So 6 squared plus 11 squared, working in our calculator, we would get 157. 4 squared plus 8 squared will give us an 80. And 5 squared plus 7 squared will give us 74. Once you have those values, you can begin to do a comparison. So on this one, when I compare my c squared to the sum of the squares of the other side, my c squared is larger. Since the c squared is larger, my triangle must be obtuse. On the next one, since my c squared equals the sum of the squares of the other two sides, my triangle must be a right triangle. And on the last one, since my c squared is smaller than the squares of the sum of the squares of the other two sides, this one's going to be less, my triangle must be acute. The last thing that is an important idea is understanding what is called a Pythagorean triple. A Pythagorean triple is simply a set of three numbers that form a right triangle, and at the same time, they are all whole numbers. So for example, if we wanted to look at example B, where we know that these three values do form a right triangle, these three values would not be a Pythagorean triple because although they form the right triangle, they are not all whole numbers. 4 square root of 5 would actually be a decimal if we tried to put that in our calculator. So to fill this in, which triangle above is a right triangle? That was triangle B, example B here. Is it a Pythagorean triple? No. And again, we can write that explanation that we just did because the sides aren't whole numbers. So that's an important feature. That's all that we need to understand for your homework packet in terms of the Pythagorean theorem, and we will begin applying this in class next time. And just to leave you with a good thought, just remember, there are ninjas everywhere, especially on rooftops, so keep your heads up and stay safe out there.